Hi all, this is Sarath and my topic is rail track inspection using autonomous aerial drones. Let's start by looking at why safety inspections are essential in first place. Rail networks are regularly accessed by millions of people and helps move billions of tons of cargo on an annual basis. So, in order to ensure the safety of both these cargoes and the human lives involved and the associated business operations, it's essential that regular safety inspections are performed. So looking at the current safety inspection methods, it's mostly done manually. And currently, it basically involves a railway safety officer walking down the track and visually inspecting for damages, if any. So this method is highly prone to human error and is often time-consuming and expensive. On top of this, railway tracks pose a severe operational hazards for the safety officers involved. Alternative inspection methods involve the use of unmanned aerial vehicle and is being thoroughly tested as a prospective alternative. So when compared to human inspections, this method is much quicker, efficient, and safer. So it usually involves four steps. The first step being UAV image capture, then followed by image pre-processing, image segmentation, and defect detection. So, as far as gaps with respect to reviewed literature, there were three main gaps. So, currently available method involves manually operating the UAV to capture the track images and use it for further process. And the robustness of most of the proposed methods have not been thoroughly tested for various environmental factors. And the computer vision and deep learning algorithms that gave the best possible results in each step of the process in separate individual research experiments have not been put together and tested in combination. So these are all three main gaps identified. And the couple of research questions that I'm trying to answer through this research are, can flight path planning software be used to achieve complete autonomous UAV flight to capture rail track images? And the second question is, can the identified best image pre-processing, image segmentation, defect detection algorithms be used in combination to identify surface defects with an improved efficiency? So my research design has four steps. The first step being image capture using an UAV. So I'm using a Staker BG300 drone equipped with RGB sensors to capture the rail track images. And risk star algorithm and borderline algorithm is basically used to achieve autonomous flight. Step two involves image pre-processing. Pre-processing was done using local Weber-like contrast algorithm and grayscale maximum entropy algorithm, followed by image filtration through first order derivative of Gaussian method. So this step is done basically to reduce interference in noise levels. And step three is image segmentation. So deep learning based railway boundary guide network algorithm is used for image segmentation, and segmentation accuracy is measured by intersection over unit scores. So defect detection is carried out by visual group geometry, deep convolution neural network architecture, and the above experiment is basically repeated under different environmental conditions to check for the proposed algorithm's robustness against various environmental factors such as brightness and wind speed. Yeah. So the findings of these experiments uh, reveal that the combined use of risk K-star and borderline algorithm was successful in achieving autonomous flight, and the path efficiency and the capability to avoid obstacles were put to test under demo runs, and the simulation flights were successful. And the suggested algorithm was able to identify surface defects with a precision of 93%, 100% defect identification rate, and had a recall of 55%. So, yeah, and the above mentioned results remain consistent with different environmental conditions. Yeah. So, with respect to gaps in the proposed work, the experiment basically limits itself to the identification of surface defects and not to other type of defects. And further research work is needed to prove the effectiveness of the proposed algorithm in identification of other types of defects. So, if you have any questions, please feel free to send across an email to this particular email ID. And thanks for your time.